So, distinguished guests, ladies and gentlemen, good morning everybody. Our CEO, Mr. Ulla Rullen, had been scheduled to do this presentation. Unfortunately, he asked me to pass on his disappointments and regrets that he was unable to be here to deliver this for you. So it falls upon me to emulate a young and very dynamic CEO and do my best in delivering his presentation. What I'd like to talk about quickly is about shaping smart change in the world. We've seen a number of facts on the screen today, and I'm going to add a few more, I'm afraid. Obvious facts: the population of the world is growing. It is also ageing, and it is also moving. And this puts pressure on infrastructure and resources. And this is shaping change that leads to opportunities for us. What do those opportunities mean in the Asia-Pacific area? About half the world's population and about 30% of the world's landmass contributes to the Asia region. The Asia-Pacific nations continue to build some of the most advanced infrastructure systems that we've seen. Just look out the window of your hotel and about a kilometre away you can see a good example of that. 80% of the infrastructure investment in energy and transport in the next 10 years will happen in our region. We see that global energy requirements over the next couple of decades up to 2030 will be at around 1.5%. In the Asia-Pacific region, it's going to be almost double that. The region is home to more than half of the 20 largest cities in the world. Half of the population of the region by 2028 is going to be in cities, and it'll be 2/3 by the middle of the century. And on top of that, just to make it even more interesting, the region is prone to natural disasters. About half of the world's natural disasters in the past 30 years have occurred in the Asian region. We have two large ocean systems on either side of the region. We straddle the climate challenges of the tropical belt, and if that wasn't enough, we also sit on the Pacific Ring of Fire. So all of these things obviously create a multitude of opportunities. So what we need to do is we need to harness this opportunity, and it means riding a wave. We talk about the smart enterprise wave, that it's going to disrupt pretty much every major sector of the global economy and dramatically improve productivity over the coming periods. The decision-making process is central to how industries are going to conduct their business and create value. And this has all been complicated by an enormous growth of data. Data is actually becoming a new natural resource, if you like. And I love these statistics. Everyone likes statistics, but these are one of my favourites. So from the start of recorded time until 2003, we created 5 exabytes of data. 5 exabytes. So like many of you, I had to go onto Google this morning and I had to find out what an exabyte is. And it's a 5 followed by 18 zeros. So you can just about get it on a piece of A4 paper. It's a very big number. In 2011, we didn't just double the amount of data that had been created from the start of recorded time to 2003. No. By 2011, we were generating that amount of data every 2 days. So just think about that. So from the start of recorded time to 2003, 5 exabytes. And now, 2011, every 2 days. And today it's even faster. Today it's about every 10 minutes. This is a phenomenal amount of data. And more data leads to complexity, it leads to different formatting, it also leads to silos. So one of the problems that we have today is this failure to break down data silos costs an organisation significantly in terms of its agility, productivity and its responsiveness. So the nature of the smart enterprise that we're talking about uncomplicates the data, and in particular it breaks down these data silos. It confronts difficult technological challenges to do so, and also I should add cultural issues as well within those silos, within an organisation, and we leverage all of that to provide actionable information. And this is the basis of the smart enterprise. So a smart enterprise would use Things such as sensors, situational awareness, notification information delivery systems, operations, workflow, incident and emergency management and monitoring to provide decisions that can be agile, intuitive, integrated, predictive, efficient, and probably the most important thing, as near as real time as we can possibly get it. And within this framework of the smart enterprise, we talk about the Hexagon Advantage. So the Hexagon Advantage enables the smart enterprise. And essentially what we're talking about here is we can measure the real world. We've got lots and lots of different sensors within the technology of the group to measure things. At the same time, we have the information, the digital systems for us to, the software to enable the digital aspects of it. And this results in a virtuous circle where we measure things, we bring it into the digital world, we design things, and we take it back into the real world. And the speed of this circle is what we're talking about in terms of the smart enterprise. So I've just been talking about silos and how you shouldn't have them. So what we've done is we've put all of our various opportunities for smart enterprise into silos. We have a safety silo built upon our geospatial and industrial foundation technologies. And within there we have public safety, security, defence, etc. We have an infrastructure area, smart infrastructure, construction, cities, transportation networks, power and water systems. We have a smart resource area, energy, food, land, etc. And finally, smart manufacturing, automotive, aerospace, etc. So our smart solutions are built from these custom combinations of geospatial information and or our industrial technologies. And you can see a number of these, and I'm very pleased to say many of them happen to go across the silos. What I'd like to do for the next few moments is just draw your attention to 5 of these smart areas, smart solutions that we're working with. Smart cities. So every day around the world, cities and the urban environment grows by about 180,000 people. 180,000 people a day. These cities are actually very complex systems. In fact, they're not just systems, they're systems of systems. So we have a transportation system, we have an electricity system, we have a water distribution system, we have all sorts of systems within the city. The city itself is a very, very important thing in the modern world. It provides a lot of sustainable growth to us. Think of everything. About 80% of that is tied up in land and the built environment. So an enormous amount of our wealth is tied up in land and the built environment, and in particular cities, where we all know the cost of land in the cities is exceedingly high. Having said that, half of the world's countries do not have a cadastral system. Not even a basic cadastral system. So if they had 2D cadastral systems, that would help. The problem is a city is not a 2D city. It's a 3D city. It's in 3 dimensions. So what I'd like to do is show you a very short video of how we're working on this challenge. The big challenge of a 3D cadastre is you have to know where the buildings are. So here you can see we're building up a model of a city. You can see the buildings being extruded from the model. Here they all come. Yep, there they all come. And then through the use of oblique imagery, we can render the sides of the buildings, and we can deliver this to our customers. This particular example is a good example because this was done in a very quick time. So the flying was done on a Monday, and the 3D city model was delivered to our customer, the Zurich City, on the Friday. So a very, very fast turnaround time in this smart city example. So that, as we said, gives us a 3D model. Great, so what? We can now start to make decisions based upon this model. Here's a very good example. One of the reasons they wanted to do this was the city wanted to understand how much electricity, solar electricity, they could generate from their city. So we managed to classify all the roofs based on the angle of the roof and also the direction in which it points. So this is a good example of how we can use this technology to make smart decisions. The next one I'd like to quickly touch on is smart water, smart H2O. I think we're all familiar with this story. A town starts on a river because that's the easiest place to get over the river, and it had a secure water supply. And the town grows, and eventually it needs some power, so someone has a great idea, they dam the river, and the next thing you know, you've got a big city several kilometres downstream from a very large dam. Obviously there are safety implications associated with that. Now we have systems to measure the dam. Latterly we've been using UAVs, but we have all sorts of other systems to do that. But what we talk about in a smart solution is bringing together the various sensors that we do have and combining that in some sort of a data sensor with not just the sensors on the dam and the structural integrity of the dam, but also water levels, meteorological information. We bring that into a data center. We can process that information, and we can manage people in the field, send information out to the field. We talk about mobility, things coming back in, but it all being controlled through one area. And this helps us reduce the risk and safeguard against disaster. And if there is, God forbid, a disaster, then it allows us to respond to it very, very quickly and minimising damages, obviously. Another example is in smart mining. The challenge in mining is twofold. One is we hear about all this growth, you've heard all the great statistics, but it means from a mining perspective that we're going to need to produce about twice as much stuff out of the ground by the middle of the century as we do today. So a lot more mining. The big challenge in mining is a lot of this stuff, the easy stuff, has already gone. So not only do we have to produce more, but we need to produce more in more challenging environments, politically and also in terms of their environments of where they are physically. It means that the mines themselves are also getting much steeper and deeper. So there's more challenging in the mines. So what we've been doing here is we've been combining our mine operations area where we manage the productivity of fleets of trucks and shovels and drag lines, and we've been combining that with our mine monitoring systems, bringing that together so that the guys that are in the mine doing the work, working the shovels, etc., they know there's a system that is monitoring the mine to tell them in a predictable way if there's going to be a problem and to tell them with plenty of time to get out. So again, this is more about productivity, linking productivity and safety. Another area that we're looking at is smart agriculture. I think it was the Millennium Development Goals, one of which in 2000 was to cut the number of people that were hungry every day by half by 2015. Agriculture is interesting because we all think of it as farming, but it's not just farming. It's much, much more than farming. There's research, there's technological development, there's sowing, there's harvesting. Once you've gathered the crop, you need to store it. Once you've stored it, you need to process it. Once you've processed it, you need to move it to markets. So it's a big, long chain of events. A good example here is in India. We're going to have a lot more people to feed by 2015. I think 9 billion is the figure. In India, at the moment, currently, the farmers are actually not so bad. They're pretty efficient. But half of the product in India doesn't make it to the market for other reasons. So these are challenges for us. And what we're doing at Hexagon is we're combining a number of our technologies. So we can do the mapping, we've got the airborne sensors, we've got the UAVs, we can bring that together inside our GIS systems, and we can design the best ways to farm a piece of land. We can sculpt the land so it's as efficient as possible. We can provide a pattern of the best way to crop it. We can put information into tractors, we can automate the tractors to follow those designs very, very precisely, and we can maximise the output from agricultural land. And I'll just finish up with one more example of our smart technologies, and this is smart fusion. This is an image of an oil and gas plant. It's very, very complicated, as you can see. Traditionally, these have been described in what's called a process and instrumentation diagram, a P and ID. This is the diagram here. It's probably a bit too far for some of you guys, but it doesn't matter. If you're a surveyor like me, you won't understand it anyway. However, on the right-hand side is a 3D point cloud which has been coloured. So each of the points in the point cloud has a colour which approximates reality. And you can see that that is the inside of a plant. And on that we can geotag certain items and we can cross-reference them to items on the P and ID. So it means that the process engineer is very happy with this P&ID diagram, can look at a valve, and he can see what it actually looks like in the real world. And similarly, an inspector in the plant can be walking around and see a leaky valve and go, it's this one, and he can tell the guys back in the process area which valve it is. They can go into the system and they can see all the maintenance records, etc., that they need to repair and fix that particular valve. And I think this really takes us to where we're going with all this smart technology. I think what happens here, we see a glimpse of the future in the plant area. Here there is a physical plant. You can put your hand on it. And behind that, there's also a digital plant, which consists not just of a model of the plant, if you like, but also all of the information relating to the various elements within the plant. And the two are actually a reflection of each other. So the digital plant is a reflection of the physical plant, and vice versa. As people do the design in the digital world, they put it into the real world and it goes back round. So we go back to the large circle that we were talking about. I think at the core of shaping the smart change, it's all about solving problems that matter to industries that run our world. A very broad statement. I think, though, just to finish up from my personal perspective, I think what is so exciting about this stuff is underpinning all of it is geospatial technologies. And we're all professionals in that area, so it looks very, very good for us as a profession. I think I would go further and say it's also taking our technologies into the hands of many, many more people. And those people are the ones that are going to help us to shape the world as we go forward. So I hope that you all have a very good couple of days here at the conference, and I would like to wish you all a very good morning. Thank you very much.